we will prove the CR equations in Cartesian coordinates. The statement is this: f of z is an analytic function, then f of z is equal to u plus iv satisfies the CR equations, namely dou u by dou x is equal to dou v by dou y, and dou u by dou y is equal to minus dou v by dou x. And of course this CR equations is going to be an important one in an analytic function. So the proof in Cartesian coordinates is given here. F of z is analytic, and you know that if it is analytic, it is not differentiable at a particular point, it is also differentiable at a neighborhood. That is, when you take a point with some contour with radius epsilon, then it has to be differentiable at every point inside the neighborhood. This is the definition of the analytic function. So in this case what we do is, I use the formula for the derivative f dash of z is limit z delta z tending to 0 f of z plus delta z minus f of z whole divided by delta z, and you know that f of z is equal to u plus iv. I have rewritten f of z in terms of u of x comma y and u of x plus delta x comma y plus delta y. Similarly for v. And as I told you that f of z is analytic, it is differentiable at 2 points, or it is differentiable at the points in the neighborhood. So suppose if I take this point as x comma y and this point as x plus delta x comma y plus delta y. Okay. So now here I have two limits, delta x tending to 0 and delta y tending to 0. I will first allow delta x tending to 0 and then allow delta y tending to 0. So in the case that delta x tending to 0, I will move like this. I will move like this. Delta x tending to 0, and then I will move delta y tending to 0. Okay. So now when delta x tends to 0, it moves horizontally, and when delta y tends to 0, it moves vertically. Okay. So when I allow delta x tending to 0 first and then delta y tending to 0, I will have like this limit delta y tending to 0. Wherever I have this delta x, that has been replaced with 0. Okay. So now you can see the difference here. So now this, when I rewrite it in terms of partial derivative, I have an expression for f dash of z, which will be minus I dou u by dou y plus dou v by dou y. You should also remember this particular formula, because this we will be using it in the problems for finding the function f of z. So now what I have done is, I have allowed delta x tending to 0 first, and then when I take delta y tending to 0, I get an expression for f dash of z. Now in the same equation, I allow delta y tending to 0 first. So it will be like this. Okay. If I take this point as x comma y and this point as x plus delta x comma y plus delta y. Okay. Now what I will do is, I will proceed like this. Okay. I will first take delta y tending to 0 and then delta x tending to 0. I move like this, move vertically first and then horizontally. So when I do it, I will have f dash of z is equal to dou u by dou x plus I dou v by dou x. And as I told you, you should also remember this because while solving problems or while finding the function f of z, we may require this particular formula. So now I have another expression for f dash of zb, and when I equate the real and imaginary parts for a and b, I get the CR equations, namely dou u by dou x is equal to dou v by dou y, and dou u by dou y is equal to minus dou v by dou x. These are all called as the CR equations, and as I told you, you remember the two expressions for f dash of z. This completes the proof of this theorem. So in this case, the necessary condition for a function f of z to be analytic is that it has to satisfy the CR equations, namely dou u by dou x is equal to dou v by dou y, and dou u by dou y is equal to minus dou v by dou x.